Here we'll cover inverse of a matrix from the matrix polynomial. As you know, what is matrix polynomial? Whenever any polynomial will be given and in place of that x, if any square matrix 2 cross 2 or 3 cross 3 or higher order will be given, if this will satisfy the polynomial equation, then we can say that this is the matrix polynomial. Here the question is given, we can let the matrix already satisfied the polynomial. So here the question is given, A, 1 square matrix 2 minus 3 3 4 satisfies the equation x square minus 6x plus 17 equals to 0. So in the matrix form, what we can write, a square minus 6a plus 17i as the order n equals to 2. Here you can write 17i2, and in place of that 0, we know that whenever we write it as a matrix polynomial, so the value 0 in the matrix form, it will be 1 0 matrix, that is big 0, right? So here no need to find out any adjoint. Without finding out the adjoint or any cofactor, with the help of matrix polynomial, you have to find directly the inverse of a matrix. How it will works? So first, a square minus 6a will be that part, will be on that side. So 0 matrix or null matrix minus 17i2, which is nothing but minus 17i2, right? Now multiplying, or better to write pre-multiplying both side by A inverse. So what is that pre-multiplying and the post-multiplying? Pre-multiplying, I'm writing it. What is pre-multiplying? Suppose one matrix B is given. I want to multiply any inverse or any matrix before that, then it will be pre-multiplication. So if the matrix B is given, what is post-multiplication? That is, if the multiplication of any other matrix just right side of that matrix, then it will be our post-multiplication. It will be our pre-multiplication. So pre-multiplication, that is that A inverse will come let portion. So it will be a square minus 6a equals to minus 17 I2, or better to write here also in the both side, it will be applied minus 17 into pre-multiplication of A inverse. Now that A inverse will be multiplied with this as well as with this, right? So A inverse into A square minus 6, the constant will come outside, and A inverse into A equals to minus 17 into, as you know that identity, if we multiply identity matrix with any matrix, then the result will be the given matrix. So here A inverse into I2 will be nothing but A inverse. Clear? Now it will be 2 minus 1, that is A. Here one of the most important property, we know that A into A inverse or A inverse into A will be always I. So we can apply this property also. Here also you can write, in this step you can write A inverse into I, that is A inverse. If you write, then it will be much more easier to understand. We'll check your copy because these steps are very much important. You have to write. So A inverse into A will be your I2 minus 17 A inverse. So if we exchange the side, then write A2 minus 3, 3, 4 into minus 1, 0, 0, 1, because minus 6 is multiplied with this identity matrix, right? Now just calculate here. 2 minus 3, 3, 4 minus, this is the scalar multiplication 6, 0, 0, 6, and the result is minus 4, minus 3, 3, and minus 2. So in the next step, we can write A inverse equals to 1 by minus 17 into that matrix, minus 4, minus 3, 3, minus 2. So if we take minus common, then it will be 1 by 17 into 4, 3. It will be minus 3 as we are taking minus 1 common. So value of A inverse, you can write this, or you can write in this way: 4 by 17, 3 by 17, minus 3 by 17, 2 by 17. So this will be your answer. So without the help of any cofactor here, no need to find out any cofactor, any adjoint. You can, from that matrix polynomial, you have to solve. Whenever the question will be coming in this way, the question will be like this. You have to find matrix inverse from the matrix polynomial. You have to apply this process. You can easily find out the matrix inverse without the help of adjoint or cofactor matrix. Next topic is, and the last topic in this chapter, is you have to solve matrix equation. How will you solve matrix equation? The question is given. One matrix 1, minus 4, 3, minus 2 into another matrix X, and one matrix also given minus 16, minus 6, 7, 2. You have to find X matrix, right? How will you solve? So first you have to let this one will be your A matrix and this one will be your B matrix. So what will be the matrix equation? AX equals to B. So just now I have discussed what is the pre-multiplication. So to cancel, as you have to find out the value of x, so you need the cancellation of a here. So pre-multiplication of A inverse is our requirement. So first, from that matrix, this type of sums, how will you solve? So whenever any matrix equation will be given, first you have to write it in the matrix equation form. Then you have to identify what type of multiplication with which inverse is our requirement. So here, this is the given matrix equation. So here, first you have to write A and B, these are the matrix. So you have to write the matrix equation, Ax equals to B. Now we have to omit that part, that A. So you need pre-multiplication. I'm writing pre-multiplication of A inverse, because that A inverse can omit or can remove that A part, and the remaining part will be your X, and you can easily find out. So here A inverse into A into X will be equals to A inverse into B, right? So as we know that A inverse into A means I, here the order of A is 2, so you can write it as I2 also. So I2 into X will be your A inverse into B. So X will be your A inverse into B, right? As we know that identity matrix, if you multiply identity matrix with any matrix, the result will be that matrix. So directly in that step, I into X, that is, I have written X, right? So now what you have to do, you have to find out that case, right? Here A inverse is our requirement. So first write A 1 minus 4 3 minus 2. Clear? Now find out for A inverse, what is our requirement. To find any inverse, you know that it should be our non-singular matrix. So how will you check? First find out the determinant value and check whether the value is 0 or non-zero. So first find the determinant value. Here we can write minus 2 minus of minus 12, that is minus 2 plus 12, value is 10, right? So this is not equals to 0. A inverse exists, right? Now find the adjoint of A. Adjoint of A equals to, you can use the shortcut method. Also you can find the C11, C12, C13, C11, C12, C11, C12, C21, C22. You have to find this and its transpose. I'm writing it directly. What will be your adjoint value? Just minus 2. I'm using the shortcut rule. Minus 2, and this one will be your 1, interchanging the place, and just interchange the sign, not the place. This will be your adjoint. So A inverse will be your 1 by det A into adjoint of A, so which is nothing but 1 by 10 into -2, 4, -3, 1. So please, I'll tell you, please don't multiply that number over there. Don't multiply that scalar multiplication. Don't apply the scalar multiplication here. Why? Here, our target is to find out the value of x. So 1 by 10 into, you can write -2, 4, -3, 1 into, write the b. What is our b? -16, -16, -6, 7, 2. Why I'm not multiplying? Because if we multiply, then that part will come fraction. So to avoid the fractional part, it will be the calculation part will be much more critical. So after that A inverse, product of A inverse and that adjoint part, better to say the product of that adjoint, this is nothing but the adjoint of A into B, and here 1 by data. If we multiply these two, after that, after their result, if we multiply 1 by data, that is the scalar multiplication, then no such maximum cases, no such fractional part will come. So what will be the product of these two? It will come, just find the product. It will come, sorry, the result will be 60, 20, 55, 20. Now if we multiply, this will be 6, 2, 11 by 2 and 2. So this will be the result. This will be your answer. So using matrix equation, here the matrix equation will be given. From that matrix equation, you have to find out one unknown matrix. So these are the steps. If you follow, then you can easily solve and you can do this type of sums.